But if we haven't met yet, by the way, my name is Matt Oztalay. I'm a Senior Developer Relations Technical Artist at Epic Games. And we are here in the Crop Out Sample Project. And in the Crop Out Sample Project, our little villagers, they have invented canoes. They figured out how to build canoes. And they're really excited about these canoes, and they want to take these canoes. They see this new island kind of off in the distance, and they want to go to that little island instead of just staying on their own. They have ambition. But it's really far away, that island. And so the villager, he thinks to himself, I'll pack a bunch of snacks. I'll pack some snacks with me so that when I go out to this new island, I don't get hungry along the way. Well, it turns out that island's pretty far away, so he packs a bunch of snacks, and the inevitable happens, he thinks. But that's okay, he thinks. I'll strap a couple of boats together. I can fit more snacks in more boats, and then I can go further, right? Well, more boats are heavier. It's harder to paddle. So he's like, all right, well, what am I going to do about this? Well, maybe he brings a friend. He says, me and my buddy, we can both paddle these canoes, and it'll be great. But that buddy needs snacks, and those boats weigh more. And maybe eventually they find the right combination of villagers and snacks and boats, and they're able to make it to the new island. But maybe along the way they had some problems. We didn't get all of our canoes with us. Maybe not all of our buddies made it. We lost some snacks along the way. And you start thinking to yourself, okay, well, what if I wanted to go back home? Do I need to do this whole process again of building a bunch of canoes, getting a bunch of friends, getting a bunch of snacks together? And you're like, there's got to be a better way, right? Maybe canoes are not the right way to do it. And you're like, if I had a super yacht, all of my friends would be traveling in luxury. We'd be having a great time. Or maybe you think about building a tanker ship, because that would hold all your snacks, no problem, right? But these require metalworking, and you're more familiar with building stuff out of wood, out of trees. You don't really want to get into welding, investing in all that infrastructure or all that equipment. And you want to work with what you know. And one thing you can build out of wood is a sailboat. Right? That would hold all your buddies. You can build it out of wood, out of the materials that you know how to use, and you can use those sails to power you along the way so that maybe you don't have to row the entire way to the next island over. And it would have room for your buddies and your snacks. Okay, I think I've beat that dead horse long enough. I'm talking about blueprints. Because it turns out, like when you start working with Unreal Engine and you start building things with blueprints, you have a set of very basic tools, like the canoe. We do stuff on tick, we do stuff on begin play, we cast to things, maybe we use timelines or level blueprints, or we do some abusive things to save game, to manage state between sessions. But those tools can be pretty limiting, right? The canoe can only take us so far, and we can only do it so repeatably. But the tricky thing about moving from canoes to sailboats is that even though we're using the same materials, the construction techniques are a little different. And a canoe, I can build it upside down, inside out, or outside in, depending on how you set it up. But I can build it in like a week, and I can teach you how to build a canoe in like a week. But sailboats, you have to build from the keel up, outside in, which is kind of a different way to think about it. To build something that big, you need a boathouse. You need a little bit of infrastructure so that you can build something that big. And it turns out it takes a really long time to build a 40-foot wooden sailboat. And it's a little tricky because yes, we know how to build a canoe. Yes, we know how to work with wood. But it's a little trickier to figure out what the next step is, what the tools are that we need to scale up our use of our materials. So I want to show you what that looks like. I don't want this to be a draw the rest of the owl kind of talk, but I'm not going to be able to draw the whole owl in front of you because, again, it turns out it takes a lot longer to build a 40-foot sailboat. So I want to show you some of the intermediate steps to kind of taking your blueprints to the next level without going into each individual implementation detail. I want to show you the concepts, expose you to some of the new tools without going into the nitty-gritty details. Because ultimately, it's all about trade-offs. How we go about building our game, building our framework, is a trade-off between our time, our efficiency, what do we need to do? How many friends do we need to bring with us to the next island? In what level of comfort or luxury, or how many snacks? And the other big kind of consideration is your tolerance for a lack of visible progress. Because if you start out and you're building your boat, if you start out and you build your canoe and you like put a plank on the canoe, great. Your percent of boat that you have completed is higher now. But then eventually you're kind of going to tap out on how much boat you can complete because you've just been focusing on building the boat. But if you spend some time building out the infrastructure to build the boat, building your boathouse, getting your planks, building your lumber so that you can set yourself up for success, now it gets a lot easier to build a bigger boat because you started out building the tools, using the techniques that you needed early on. So these are some of the things that we're going to talk about today. This is a very big list. These are a lot of heavy concepts. Each of these is its own separate talk or live stream. But I'm going to talk about each of these in a context as we go. I'll point them out, talk a little bit about how they work. And the context that I want to do this in is Crop Out New Shores, a DLC expansion pack for the Crop Out sample project. And I want to show you what that looks like. So we want our villagers to go to a new island with all of the resources that they had because they spent a bunch of time growing the food and cutting down the lumber and gathering the stone. We don't want to leave all that behind. So I've added a couple of things to the game. I've added a library, and in the library, I can research things. I added a tech tree mechanic to the base game. And as it's researching things, it's going to go through. The villagers are reading books and doing tests and building out their little tech tree. And then once they've finished researching it, they can now build a sailboat if we have enough resources. So I'm just going to add myself a few resources there. So now we can build a sailboat. And I can go and place the sailboat in the water over here. And we can build it. And we can tell our little villagers to go, hey, could you please build that sailboat? Please go build that sailboat. And as they're going to build out the sailboat, we'll be able to double click on the sailboat and sail to a new island with all of our resources. So the way I went about doing this is I added the tech tree mechanic to the base game, which is going to let me talk about gameplay tags, which is a really fun little feature. I extended the build menu so that I could use a game feature plugin to add the boat to the game without having to do some trickery inside the base build menu. We're going to talk about data persistence. When we go to the new island, we're going to drag all those resources with us, and we can start out on a new island. So, the core big things, we changed the way we do buildables so that we can extend that menu. We did the tech tree mechanic, and the boats are a game feature plugin. And I'm not going to talk about it in this order because, again, this is kind of as you get more complex, the interrelationships between things become more complex, and not quite a linear flow. So the first thing I want to talk about are game feature plugins. And all we got to do to enable these in our project is the game features plugin and the modular gameplay. And that lets me, from the new plugins menu, add game feature plugins. So if I click on a new one, it will go into the plugin game features folder. And these are really powerful tools because if we build our features in game feature plugins, we have to build them modularly. It forces us to not have a bunch of interrelated dependencies. And what's really nice about them is that if something breaks in a game feature plugin, you can just disable the plugin and test the rest of your game without that one feature completely failing all of your tests. So when we make a new game feature plugin, it will create a data asset, and this data asset is our game feature data. You can see up here we've got the current state. This is the kind of important thing. When it is active or when it is activated, we run through all of these actions, and I've got one set up already. We'll show you some cool stuff about this. And the kind of core of this is that I can turn it to registered, and now I can start making changes to it. I can add actions to it, and you can extend these actions with C++ if you want to get into a little bit of metalworking. If not, we still have add components, and add components is a really easy action. All it does is when the plugin is activated, when we begin play, we will know that we will add a component of our choosing to something like the buildings. Maybe I want to make a holiday event that I can toggle at runtime based on what day it is, and so I'll add maybe a Christmas tree to our to all of the buildings in the game. So I'll come in here and I'll make a static mesh component. We'll call it BBC tree. Go into this. I'll set this to the tree mesh. There we go, set that to the tree mesh, and then I'm going to offset it in Z like 200 units so that we can see it. We'll compile and save that, and then in the plugin I say, all right, add to the BP building base our BPC tree, all right? So now I'm going to activate the plugin, reactivate the plugin, and we'll go to our building base. And in the building base class, all I had to do is use this game framework component manager, add a receiver. So this is telling the system, hey, on begin play, I should be able to receive new components from whatever game feature plugins are active. So now, when we go into our game and we go play in editor, we go find our, where did it go? Where did it go? All right, let's build our library. Let's put it there. Now you can see I've got a tree hovering over our library because we added that component to all of the building base classes, right? That's not a super complicated example. I wanted to show you a little technique that we can expand on further. And the way that we did that is in the original crop out game in the build UI, it uses a data table, get data table row names, iterates over all of those, and it uses that, the information in that data table, to create a widget with the cost of the thing that we want to build in whatever build class we want to actually build. This is not an extensible or componentized way to do things. If I wanted to, you can't add to a data table at runtime. I can't inject data into it. But you can do that with things that are called data registries, which I kind of think of as modular data tables. So in my project, I created a couple of data registries, one for buildables and one for our tech tree mechanic. Important thing to do when you are setting these up in your project settings, make sure that you have a directories to scan so that the game knows where all your data registries live. And then in the base data registry, you can see I've got two data sources. One of them is a data table source that points to the original data table for all of the buildables. And I've got this data table meta source because in my game feature plugin, what I can do is add a data registry source. So I can say add the contents of this data table to this data registry. So this string right here, this name, matches this name. Very important to make sure that the registry type and the registry to add to are the same. Ask me how I know. So then what I can do in the build menu, in the build UI, in the graph, you see I've highlighted a change. I iterate over all of the items in the data registry. And then I continue to do the same thing. Get the items from the data registry and use that to build that widget. Now, unfortunately, I had to do a tiny bit of metalworking to get the sailboat built. So there was just a little bit of C++ that we needed to iterate over the contents of a data registry. Don't worry, this is going to be a snippet available in the links at the end of the show, just a tiny little bit of C++. But there are a dozen other ways that we could have done this. We could have just set up a blueprint on our game mode that we just add all of the different components that reference all of our different buildables, for example. Okay. So we've talked a little bit about how we are referencing or the kinds of things that we're doing to get at all of this data, but we're not really talking about how we're storing that data. And this is another one of these features of the engine that when you're starting out, when you're building your game, everything will be what is called a hard reference. It is a direct reference to the thing in memory. But soft references are a little softer. They point to the address where a thing lives and not to the actual thing itself. And it allows us to more efficiently reference this content. And we can see this in the base game. So in base cropout, the target class of the struct that's stored in the data table is a soft reference. So you can see over here, it's just the path to the class and nothing else. So that when we load the data table, we don't have to load all of the blueprints and all of the static meshes that are represented by that blueprint and all of the materials that are referenced by that static mesh and all of the textures that are referenced by that material. Because you can get to a point in your projects where opening this data table can take minutes because the engine has to go through and load all of that stuff into memory because you have created a hard reference to it. Which is not to say that everything in your game has to be a soft reference. if you know that you're going to need something at the exact same time as that thing, like textures in a material, that's a perfectly reasonable way to create a hard reference. But for something like a data table, soft references, I think, are absolutely the way to go. Soft references, by the way, are a whole separate talk that is linked in all of the stuff at the end of the show. But they're really great for breaking up complex dependency trees. And speaking of trees, let's talk about the tech tree mechanic. So like I said, I added a library to the base game, and you can see that it is a library because it has a book on top of it. And I need a way to make this interactable. The player can interact with this, because I didn't want to add another button down on the bottom that's like tech tree. I wanted it to be something that is contextual to the library itself. And there's a couple of ways that we could have done this. But I also want to be able to interact with villagers when I double click on a villager. But what I probably don't want to do is go up above, because villagers and buildings, they meet back together at actor, at the base actor class. But I don't really want to go all the way up to actor to add my interactive functionality. And I might want to add some kind of interactive functionality to everything else later. Now, the way we might have done this with our canoe is that we would have said, hey, when you click on something, cast to an interactable, and then if I cast to an interactable, do something to the buildings. Okay, well, if it wasn't an interactable, maybe I cast to a villager, and if I cast to a villager, do something to villagers. There's a couple of reasons we don't want to do this. One, this does not encourage us, it does not encourage us to build modularly, because if I ever wanted to add a new thing that I could double click, I'd have to go into this blueprint and add it to this list. And maybe my designer already has this blueprint checked out, and I don't want to bother that person, so I have to wait for that, and it's a whole thing. Instead, we can do some fun stuff. But this can get really scary really quickly, where I've seen this come up. It's like, oh, when we're trying to keep track of score in a game mode, and we want to score CTF and free-for-all and King of the Hill differently, we might end up with this really deep tree of cast, fail, cast, fail, cast, fail, cast, fail, which is not ideal. This is kind of not how we want to do it. And one of the major reasons that we don't want to do it is that casts are also hard references. So if I'm casting to the villager has a hard reference to the skeletal mesh. That means that every time I load my worst case scenario casting blueprint, I also have to load the skeletal mesh for the villager. Again, this is not an ideal way of working. So we're going to find a different way to do this. Gotta drink my tea. Like I said, we're going to find a different way to do this. We're going to be more efficient about it. We're going to be more modular about it. We're going to interface. We're going to use interfaces so that we can generically interact with things without having to know what they are. It's like, imagine sending a letter to a house, to an address, but you don't know who lives at that address, and you don't know what you're going to get back. You just know, I need to send a piece of mail to an address. And if I get something back, great. And if I don't, I can assume kind of a default value. So we're going to use interfaces to set up our double-click functionality. So what I've got here is the player blueprint. This is what I want to show you where this starts, where this originates. So in the player pawn blueprint, it has some functionality to, as you move around, figure out what actor we're hovering over, and we store it in the hover actor. This is all in the base game. So all I did was I added a new enhanced input action called double click. Enhanced input is a whole separate talk. We will get to that later. But basically, when I double click on something, if I'm hovering over something, call clicked on it. You know, I don't have to cast to the thing that I am trying to reference. I just call clicked. And you know we're sending a letter to an address that we don't really know who lives there, because there's a little letter on the function node itself. So let's see what this looks like. So I want to double click on the villager. Or I want to implement something that when we click on the villager, we do a thing. So in the villager blueprint, in the class settings, I will implement an interface. I can just add my clickable interface here. And while we're here, let's go look at the clickable interface. This is just a basic kind of blueprint class you can create, and it has a bunch of functions that you can add to it. You can categorize the functions, and you're just defining function signatures. What goes in, what can come out. So I know that the clickable interface has a click function. In my blueprint, I can go to the Interfaces tab and double-click on clicked. So now I have a function node that says, hey, when somebody calls clicked on us, do the thing. And maybe what I want to do is make some fireworks. So like I'll add a Niagara particle system component. We'll use like, I don't know, we'll use like a simple explosion as our fireworks. We'll set it to auto-activate false. And now when I click on a villager, I can just activate that component and it will trigger our particle effect. Super simple. So we'll go into Play in Editor. And now I can go move my little player pawn over the villagers. And when I click on them, now it plays a little particle effect because I clicked on it. And that's all I had to do, implement the interface, do the function, because I'm already calling that function from wherever I need it to start from. So let's talk about how we're doing, let's show where we're doing that on the rest of the OWL. So on the library blueprint, I implement the clicked interface, and on the clicked and unclicked, we add a UI through the game mode. And this is also an interface. Interfaces are the crux of this talk. This is the big thing I wanted to talk about. But we've got the BPI player interface, and that lets us add an arbitrary UI to the player via the game mode. And let's go look at that UI. So when we open the tech tree UI, we create our little widgets, same as before, same as that get cached items, and we create these little widgets. And when you're building something like an RTS, you want to validate that the player has the resources they need to build the thing, or you have to have money to spend money. And we can see that in here. We've got the has research, is actively researching. You know, we make sure that the required research is there. We make sure that we've already done the research, and this is happening in a function. Because what we might think about doing, possibly, is every frame, go check and see if we have the resources that we need, right? That's kind of intuitive. It makes sense to us. It's easy to implement, like easy as building a canoe, but we all know that tick is not maybe our friend. So I want to introduce you to somebody else. I want to introduce you to event-driven gameplay so that we can avoid tick, right? Because I'm using this in a few different places so that I don't have to check stuff every frame, because checking stuff every frame is expensive. And so what you might do, what you might normally think to implement is, okay, every frame, check if a condition has been met, and then do the thing if the condition is met. But instead what we want to do is whatever is changing the condition, this should trigger an event dispatcher. So maybe I've got something down here that's like these event dispatchers, and I can say when thing done. And then maybe I've got something going on in my blueprint, and then when the thing is done, I can call when thing done. And then if I ever want anybody to interact with this, I will bind an event to this when thing done event. I'm going to show you how we're using this in a second. So in this resource check function in our buildable, this is the thing that figures out, do we have the research that we need? Are we already researching it? And then we check and we see if we have the resources to spend on it. This is not happening every frame. In fact, this is using this bind event to update resources. So the base game mode, you do have to cast for this, but the base game mode has a event dispatcher called update resources. So when the villager drops off a resource at the town hall, it's like, great, I've got a new research. Let everybody know we've updated resources, and then whoever is listening can respond accordingly, like our buildables, like our tech tree widgets. So the way that this works under the hood is when we click on the tech tree item, we tell the game mode to start researching, also an interface. On the game mode itself, we have a research component. Oh, that's why I went to that slide. Great. On the game mode itself, I've implemented that interface. Okay, start researching. What thing are we researching? Send me the struct. And then I communicate with this research component, hey, I need you to start researching. So the game mode itself doesn't keep track of this, and I can move that research component around to a bunch of different game modes if I want to. I could even make this a per player thing. Maybe I move this to the player controller. It's easier to do that because I can do it with these components. And if somebody wants to work on the game mode, I don't have to check out the game mode to make a change to the research mechanic. Okay, so the research component calls start research. In the research component, all we're doing is set component tick enabled, and that's going to let us keep track of a progress over time without ticking. Spoiler alert, you can have a little tick as a treat, but this component starts with tick enabled false so that it's not always ticking, and we can call into it to enable tick when we want it to tick, and then disable tick when we have finished researching. Really easy. Now, the other fun thing that we can do with this in our research component is we don't actually need like perfect 60 frames per second values of our research percent. Nobody's going to react to it that quickly. So what we can do in the class defaults is set the tick interval. Maybe we only need this to tick every fifth of a second because that's really about as much time or granularity as we need. We don't need, the full 60 frames. So then in our research item, what we do to have that little progress bar going is when we click on the thing, we do this set timer by event. So instead of having an actual tick in the research item, I can call this function at a fixed interval, like say every fifth of a second, and I can set it to looping. And then we can check if we're still researching, update the research percent accordingly, and then when we're done researching, we invalidate the timer, and now we're not ticking every frame. Right? Pretty nice. Okay, so that's the mechanics of how we're researching, but how are we keeping track of what we're researching? And this is where gameplay tags come into play. And these are a lot of fun. They are text-based, so if you want to add tags to a game, you don't have to check out a blueprint. You can compare tags together, and they are hierarchical. And the easiest way that we can add these is through our project settings. So I can go look for gameplay tag. And you can see I've got a tag list. It pops up this little UI. It shows me the file from which the tags were generated. And I've got crop out. I've got tech tree. And this is where I'm keeping track of all of the different possible tech tree states, right? Level 1, level 2, level 3, level 4. And gameplay tags are just a really easy way to have basically a whole list of booleans without having to explicitly define each bool on each blueprint that you want, right? I would have to have some way to, like, on the research item widget, figure out which tech tree level, maybe I do like an enum, but that's not super efficient. And gameplay tags are the way that we can do that. So when in the research component, I store the struct of what research item we're going to get. And the research item has two values, the granted research, what research will this give you? And I can say, oh, this is going to give me level 2, and level 2 requires level 1. And these are just little tags. It's just little checkboxes. It's booleans. These are great. And so in the build item, for example, I can gate whether or not you can build a thing based on whether or not you have the research. Again, also an interface. So I figure out, okay, what's the required research for the buildable? And I ask the game mode, hey, do we have the research? And then we just pass that through. Where did that go? There it is. In the tech tree, I have has research, and I ask the component, hey, do we have this? So we pass in the explicit tag, cropout.techtree.level1, and we compare it to this researched items value. So if we go into that blueprint, we have this researched items, and this is a gameplay tag container, and this allows me to store multiple tags in a single container that I can then compare. So this is where, oh, maybe each different player, because they have their own research component, this lets me keep track of their own tech tree state without having to manage it through the game mode. And again, I can just say, hey, does the tag container have this tag? Easy. That's all we're doing for the research. So gameplay tags are great. It is finally time to build our boat. So in our game feature plugin, I have a boat blueprint, and I have a data table for the boat, which is where I define the icon that we can use, which is also a soft reference. I can define the cost, tab caller, the required research, all that fun stuff is defined in that. And then in the game feature plugin, like I mentioned earlier, we add that data table to the buildables registry so that when we activate the plugin, we can add that. If we wanted to deactivate the plugin, then it wouldn't show up in that buildables menu, and we haven't had to change anything except the active state of the feature plugin. So the other thing that we want to have on the blueprint or on the boat is we also want to be able to click on it, right? I double-clicked on the boat to move to a new island. And so I implement that interface. I have this can be clicked so that when we are building, when we're building it, we can't double-click on it. We have to wait for it to finish building. And if we can click on it, we do this initiate travel to new island, which is just a fun little component. And in the component, all we're really doing is calling on the game instance transition to new island. And you're going to potentially ask yourself, Matt, what is a game instance? Because this is also one of those things that as you're building a canoe, you've probably never had to think about game instances because maybe whatever canoe you're building doesn't involve state transitions within a single session. So there are a few different ways. Could not throw this across the entire room. There are a few different ways that we can persist data within Unreal, right? Game mode lets us persist data within a single level, because when we open a new level, whatever game mode is existent in memory in Unreal gets cleared out so we can open a new game mode for whatever level we've opened. And then, if we want to persist data between sessions, we use a save game, right? It just saves out a .save file. That's a whole separate talk. But I want to talk about the game instance, because the game instance is the thing that lets us persist data from level to level while we have a session open. And this is where we're going to store all of the resources that we've gathered on Island A so that we can bring them to Island B. So, yeah, I'm going to walk over for this. So, in the game instance class, I've got in the event graph, we've got this, hey, transition to a new island. Again, also an interface function. And then we get the current resources from the game mode, also an interface function. And we store them in this little persistent resources buffer. Then we clear the save, and then we reopen the village level, because that's how it works in Cropout. So then, when we're done with this, or when we've opened the new level, what our game mode will do is, in the event graph, in the game mode, after we're done spawning in, after we've got everything set up, we'll get the resources from the game instance and add them to our game mode. So we leave the resources up in the game instance and we drag them back down when we've opened a new level, when we started a new game. That's all it takes. There's a lot we can go into with game instance. So like if you wanted to set the number of players or the team colors of people that are going into a match, and you have a main menu, and you have a game mode, you want to pass that data from the main menu to the game mode, and you do that through the game instance. Okay, I got bad news. It is not a Matt Oztalay talk if I do not talk about profiling. And the way I want to talk about profiling today, just a really brief overview, I want to show you some fun stuff. So down here in the taskbar, or in the toolbar, I think we added this in 5.2. It is the trace toolbar, and this lets us run and control Unreal Insights from within Unreal. So if I wanted to, for example, I could use this Open Insights after trace, and then I'd click that button to start tracing, and now Insights is running and tracing and storing data, and then I can turn it off, and then when we're done with the trace, it's going to pop open Unreal Insights with the trace of whatever we were just looking at, and I can dig into whatever data that I might want. But I don't know about y'all, sometimes I feel like, I love Unreal Insights, but sometimes I feel like when I'm looking at this, I'm reading the sonar readout on a submarine. And I don't know if you've ever looked at those, but that requires a lot of special brain transition mechanics. We don't know what's going on, right? We can't look out the window to see what's happening. But we have a few tools now in Unreal Insights to give us a clue about what's happening in our game. So maybe I want to profile researching. Maybe I feel like I want to know when somebody's researching something so that I can see the impact of the research tick on overall performance. But if we looked at that trace file, there was no way to see when we were researching. I might have to dig in and see, oh, the research component is all the way down there. That's a pain in the butt. So what we've added are these regions, this idea of regions. And all we have to do, using the trace utilities plugin, it defines a bunch of static blueprint nodes. So I can say trace mark region start when we start researching. And then when we finish researching, I can say mark region end. So I'm going to show you what that looks like. If you give me a second to get this set up. So we'll go into play in editor, and I will turn on my trace so that we can have all this running. And I will go tell my villagers, hey, could you please build that library for me? They're going to go build that. I'm going to take this opportunity to drink my tea again. And maybe we might have a mechanic, or we might set up a region of like, oh, is somebody building something? We could keep track of that. So now I can double click on this. I can say, give me level 2 research. It'll go through. It marked that region start when we clicked on that button. It's going to mark region end when we're done researching. And then I can close the trace. It's going to open insights again. I can scroll to the end, and you can see this timing regions track, and now I can see exactly where I was researching something in the insights file without ever having to like zoom all the way in to figure out where that component might be. This is really handy. I use this in a bunch of different places. You can have a bunch of different regions running at the same time because it's just a start time and an end time. There's no real overhead to these things. But maybe while I'm zooming in on this, I might want to find like, okay, where in this stack is the call to the research component, and maybe I'm not seeing it. Well, there's a couple of things that we can do. If we want to add a little bit of extra overhead, we can do stat named events, and we can turn on the asset load time channel, and this will give us more granular information about the blueprint calls, about all the function calls in the insights file. It's really handy. And if you, for example, are running through your level or in your plane editor or something like that, and you're like, oh, I wasn't tracing, but I really need that trace, all we have to do is a save trace snapshot, and it'll send out just the kind of rolling buffer of whatever events we were keeping track of for the last few frames or something like that. It's a really fun little like quick hit tool. And while I've got you and I've got a little bit of extra time, I want to show you another fun one, which is trace screenshots. So I can run a trace, right? Like I said, we can't look out the window, except we can. So all I have to do is call trace.screenshot in my console. I run that, and then I close the trace. Now, if I go look at the trace file, we can see this screenshot, and I can keep track of like, oh, this is what was happening at this point in the trace file, and I can see it as we go. As a heads up, it does embed like the full back buffer into the insights file. So we don't want to do this for like a 15-hour long playtest. And we have, a terabyte insights file. Okay. So what did we learn today? Well, we learned to not yell when we are hanging out with Australian game devs at the Stingray Lounge. We also learned about game feature plugins and how we can use them to modularize our content and to test and develop more efficiently. We learned about data registries so that we can composite data tables at runtime. We learned about soft references so that we can break our dependency trees. We learned about interfaces so that we can communicate with people without knowing who they actually are. We learned about event-driven gameplay, a little bit about event dispatchers so that we can avoid having to check stuff on tick every time. We also learned how to control our tick. We can even go into our project settings and disable tick by default for all of our actors. We learned about gameplay tags so that we can efficiently track a bunch of different states without having to set up a bunch of specific variables. We learned about game instance and data persistence using that. And finally, we learned about my favorite topic, which is profiling. There is, of course, so much more to explore within the world of blueprints. We didn't talk about what it might look like to nativize a blueprint to C++ code. We didn't talk about the new mover component. We definitely didn't talk about enhanced input or things like deprecation in blueprint namespaces. There's always more to explore. And speaking of which, at 2:30, there is a talk called Game Changing Inputs that you should definitely check out if you're interested in that. And at 4 o'clock, we've got to talk about exploring the new state tree. So if you're interested in gameplay at all, tech design at all, definitely check out the new state tree. And on that, this is a QR code that will take you to my link tree. In that link tree are links to Epic Developer Community articles with a bunch of resources and the snippets that I mentioned earlier. And again, please don't forget to fill out your post-show surveys. Remember, if you liked the talk, my name is Matt Oztalay. And if you didn't like the talk, my name is Chris Murphy. And on that bombshell, I'm going to open it up to questions.